there's no reason to think that the ocean ends just beyond your horizon. And likewise, there's no reason to think that the aftermath of our Big Bang ends just at the boundary of what we can see. Indeed, there are quite strong arguments that it probably goes on about 100 times further. And it may even go on so much further that all combinatorials are replicated, and there's another set of people like us sitting in a room like this. We are still groping for ideas.
But you think first theory will reach into that place, and then experiment will perhaps one day catch up?
Well, I
Maybe
think
simulation.
in a sense it's a combination. I think what we hope for is that there'll be a theory which applies to the early universe, but which also has consequences which we can test in our present-day universe, like discovering why neutrinos exist or things like that. But I think the hope would be that we will have a theory which applies under the very, very extreme early stages of the universe, but which gains credibility and gains confidence, because it also manages to account for otherwise unexplained features of the low-energy world and what people call a standard model of particle physics, where there are lots of undetermined numbers. So it may help with that.
So this is my first tutorial on the quantum Lagrangian. And in this tutorial, we're going to complete Einstein's equations for the energy of motion, and we're going to simplify the standard model. And we're going to do that using the sonic gravity Rosetta Stone of the universe, that our consciousness is surfing over the 2D holographic surface of the black hole that is our universe. Now, it's a 2D holographic surface, and our consciousness can only receive information from the hologram. And that means that only the matter and energy in contact with the hologram is what we can measure and interact with. But we'll see that even the energy off the hologram, the matter oscillating, tethered by the Higgs string to the fabric of space-time, still has gravity, and the effects of gravity are still there even though we can't interact with the matter and energy itself. In order to show that the sonic gravity theory of everything is actually the theory of everything, it has to coexist with the things that we know are true in physics. And not just coexist, it has to establish, it has to reflect it, and it has to accurately model the geometry of the universe, that the established equations in physics that we know have been tested and experimentally verified are mutually supportive, and that is fact. It can't be the theory of everything if it isn't the theory of everything. If it isn't right and the puzzle pieces don't fit, it can't be the theory of everything. But guess what? It does, and that too is a fact. And so far in our sonic gravity tutorials, we established the sonic gravity theory of everything and black hole genesis, which you really want to watch first if you haven't seen that. We talked about dark matter and the God equation, and then we derived the law of quantum gravity and the equation for quantum gravity. And so now we're going to talk about the quantum Lagrangian. And to tee that up, we got to talk about Newtonian mechanics and what the Lagrangian is. How the sum of the Lagrangian over time is the action. And then we're going to look at quantum mechanics. We're going to look at the Schrodinger equation, and we're going to see if the Schrodinger equation reflects the sonic gravity Rosetta Stone in the universe. And guess what? It does. Then we're going to talk about the Dirac equation. The Dirac equation really sort of combined the Schrodinger equation and Einstein's special relativity, Einstein's equations of motion. And guess what? It does. And we're going to see the funny thing is that Dirac couldn't get the equation to work unless he modeled it using 4 electrons, 2 opposite electron pairs. And we're going to see how that is exactly modeled by the sonic gravity theory of everything, that our consciousness exists on the surface of a 2D hologram. And if you turn it sideways and you look at all the matter and energy tethered to the fabric of space-time via the Higgs string, where that matter is oscillating in a circle, and that orbital path intersects the hologram at 2 places, sort of the 6 o'clock and the 12 o'clock position, we're going to see that the 4 electrons that Dirac needed to make his equation work are the entrance and exit points of the matter and energy that pass through the hologram at the bottom and the top of the orbital intersection with the holographic surface. And everything from the sign conventions and the orbit, where the positron, which is the negative electron, is actually going backwards in time, the electron's going forwards in time. We're going to absolutely see the sonic gravity theory of everything, the Rosetta Stone of the universe, models the charge, the time trajectory, the position, the direction, all of it. Dirac didn't know it, but his equation models the sonic gravity Rosetta Stone of the universe, and that too is a fact. And this next thing is just going to blow your mind. And if you're a physicist, when we get to the Dirac equation, it's absolutely going to blow your mind, and that is a fact. And we'll note how tension in the Higgs string, which is quantum gravity, pulls on the fabric of space-time. And I'm going to draw it, and you're going to see it right in front of your face, that Einstein's general Relativity, which established that matter and energy bend the fabric of space-time. It put a dent in the space-time, and it's that dent that causes other mass to sort of roll towards other massive objects because of gravity. And we'll see that when the Higgs string is tugging on the fabric of space-time, on the 2D holographic surface of the black hole, it's going to bend it, it's going to pull it, which is going to cause a dip. And so the sonic gravity theory of everything also exactly models general relativity, and that too is a fact. And then after that, I'm going to prove to you, according to the Velcro astronaut problem, is the illustration I just made up, but it's going to prove to you that the assumption that the scientific community makes, that mass doesn't change with velocity, that mass is constant, they're wrong. I'm going to show you inconsistencies in Einstein's equations of motion that prove it can't be right, that prove that mass must reduce as a function of velocity. And that's going to give us the relationship between mass and velocity. Knowing that knowledge is what we need to realize, that when something accelerates, it transmutes part of its mass into a dark matter state to pay for that increase in velocity, to preserve conservation of mass energy within the surface of the hologram. So something goes faster, a little piece of its mass comes off the hologram. And when something moves at light speed, all of its mass comes off the hologram. And the reason that luminal speed limit exists is because at the speed of light, there's nothing on the holograms. There's nothing to accelerate, and so that's as fast as we can accelerate something from the hologram, and that is a fact. And when we realize that the Schrodinger equation, the Dirac equation, special relativity, and general relativity are all consistent with the sonic gravity theory of everything in the Rosetta Stone of the universe, we're going to realize that the elementary particles in the standard model are the particles that are going forward in time. And when they whip around, tethered by the Higgs string, and head backwards in time, they go through the hologram at the 6 o'clock position, they go forwards in time, they arc up, and they hit the 12 o'clock position, and then they're going back in time. That is what scientists think are antiparticles. Because under the right-hand rule, they're going the wrong way, with the wrong charge, backwards through time. But it's because we have this Cartesian model in our heads, we don't realize that there's a symmetry, that's an orbiting particle. It's not a left and right particle, up and down particle. We're going to realize that the particles and antiparticles are the exact same particles. They're just going around in a circle, arcing out of and back into the hologram. And we realize that mass is a function of velocity. We're going to see that the tau, the muon, and the electron are all the same particle, just moving at different velocities. And as soon as we realize and accept that, it does violence to the standard model. It doesn't disturb anything that's measured or corroborated scientifically and experimentally under the standard model, but the interpretation of the energies and the failure to realize that as a muon created in a collision is just an electron whose light speed has been arrested by a sudden collision. So you have a big fat electron because it's got no velocity. Heavy particles produced in colliders don't decay, they just accelerate. Then it gets picked up by a positive ion and it starts to whip around it just like an electron orbits any other proton, and it achieves near luminal velocity as it rotates around that positive charged particle. And scientists think that this muon just decays and shoots out neutrinos. But neutrinos are just a marker for spacetime, and the neutrinos that scientists think they see are really just skid marks as that electron peels out. And the neutrino is really the mass action, called the Voorhees mass action, which is essentially the G's that carry away that mass of that electron as it accelerates, oscillating at near light speed. So when we see that, then it just executes, absolutely annihilates all the higher energy particles. We realize that the electron is the tau. The electron is the muon, just at different velocities. Near zero velocities immediately in the aftermath of collisions. And that's why muons decay slowly in the upper atmosphere near the poles, because there just aren't that many positive ions to pick them up. And they can even hit the ground before they get picked up by a positive ion. Anyway, yeah, it explains everything, and that too is a fact. Now I'm way behind, so I got a little bit carried away with this preview, so let me catch up on the drawing. So at the top, we're talking about Newtonian mechanics, a little classical mechanics. It's totally accepted. And we all learned this in high school, probably, maybe, I'm pretty sure. So you got kinetic energy, it's the energy of motion. You got potential energy, that's the energy of height. And if you had a rock with mass on top of this cliff, at the initial time, when the rock is on top of the cliff, all of the energy in the system is described as potential energy. It's the mass times the acceleration due to gravity times the height. Now, if that rock falls off the cliff, as the rock falls, it's going to trade its potential energy for kinetic energy. And the formula for kinetic energy is 1/2 times the mass times the velocity squared. And at the end, at time 4 in that diagram, right before the rock hits the ground, all of its energy has been converted from potential energy to kinetic energy. That is a fact. It's essentially zero height, so there's zero potential energy, and it's all velocity. Now the Lagrangian at any particular time is going to be the kinetic energy minus the potential energy. And in every instance in that time, and all times in between from the beginning to the end, the kinetic energy plus the potential energy equals the total energy, and that is a fact. We call that the Hamiltonian. And all that means is that the energy doesn't get greater and it doesn't get less. The total energy, the Hamiltonian, is a fixed number, and it equals the kinetic energy plus the potential energy at every single time. It will always be equal. And you can see from time 1 to time 2 to time 3 to time 4, during that whole time, at the beginning it was all potential, and as it falls it trades it for kinetic, and at the bottom it's all kinetic, right before it hits the ground. And since all the energy is potential energy at time 1, and all the energy is kinetic energy at time 4, but the Hamiltonian means that at the beginning, at the end, and all times in between, the potential energy plus the kinetic energy equals the Hamiltonian, equals the total energy, and that never changes, and that is a fact. And so now we come to the Schrodinger equation, which is really the inception of quantum mechanics. And so before we get to quantum mechanics, what I want to do is I want to talk about the geometry of the Rosetta Stone of the universe. The sonic gravity Rosetta Stone says that all the matter and energy is oscillating around the surface of the hologram. We can only interact with matter and energy that's on the hologram. And so in this context, in this model, the kinetic energy, just like in Newtonian mechanics that we just talked about, isn't just velocity. It's actually the appearance of the mass in the hologram, right? The observable mass. That's actually part of the sort of active kinetic energy, because E equals mc squared. Mass is energy. And so that counts in the quantum Lagrangian. The mass that you can see counts as positive kinetic energy. And that is probably a fact. Maybe, probably, I'm pretty sure. That's the sonic gravity theory of everything anyway. But the potential energy isn't height like it is in Newtonian mechanics. The potential energy is the dark matter mass energy. But it's still just like Newtonian mechanics in the sense that the kinetic energy plus the potential energy equals the Hamiltonian, equals the total energy. So in this case, the energy on the hologram plus the energy off the hologram equals the total energy, and that is a fact. And so now you can see, right, the faster something starts moving inside the hologram, well, that means that some of the other kind of energy has to come off the hologram in order for the energy to stay the same. So if something moves faster, some energy has to come off the hologram for everything to still equal the Hamiltonian, for everything to stay the same. Because in the quantum Lagrangian, there's really only 3 kinds of energy. It's either mass on the hologram, it's momentum and velocity on the hologram, or it's dark matter. And if you increase the velocity, the only thing you can do is drop some mass, and drop some mass into the dark matter condensate, so to speak. I got that from Leonard Susskind, by the way. I was watching one of his lectures. I wish I could say I made it up, but I didn't. It was from Leonard Susskind. He was talking about the Higgs field. Anyway, which is off the hologram. And anything that's off the hologram is going to be times that I. It's going to be an imaginary number, times the square root of -1. And that shows up in all the math. I don't think physicists really realize what that means, that it means off the hologram, but it does, and that is a fact. Just remember the energy on the hologram and the energy off the hologram has to equal the Hamiltonian, a fixed, constant number that represents the energy in the system. And don't get freaked out, it's really easy. It's I, which means imaginary, square root of -1, actually 0 plus the square root of -1, times the Planck constant, which is the smallest distance that we can measure anything, measure position and momentum, I should say, times the change in the energy in the wave equation, which is psi, the d psi over dt. That's just the change in the energy over time. And that equals the Hamiltonian of the wave equation. That equals the total energy in the wave equation. And that's really easy. And in Schrodinger's equation, when we realize that the Hamiltonian is actually a fixed number, it's not actually a function, and we replace the Hamiltonian of the wave equation with just a constant, because we know it's a constant, so call it h, and we integrate both sides with respect to psi, we get a real constant r plus I times psi. And that equals some constant h times the value of psi, which is the wave equation. Now don't let it confuse you. I messed up a little. I don't think 0 is a function. When I integrated with respect to psi and I brought up the new constant, I put psi times the constant r, and that's not right. It should just be a plain straight constant. But that makes sense because the energy on the hologram needs to be constant. Conservation mass energy, the Hamiltonian, all of our current Hamiltonian only concerns itself with the mass and energy on the hologram that we can interact with. And that's still still constant, and so the matter and energy on the hologram is a constant r. It's not r psi. So, sorry. But anyway, what that says is that the real component, which is all the energy on the hologram, plus the energy off the hologram, equals the Hamiltonian, equals some constant times the total energy in the wave equation. And that's a fact. So the math says that over that interval, the Planck constant, you can see in the diagram, the total energy is the energy on the hologram plus the energy off the hologram. It's completely consistent with Newtonian mechanics, and it's completely consistent with the sonic gravity theory of everything in the Rosetta Stone of the universe, and that too is a fact. So there you go. Newtonian mechanics and the Schrodinger equation, quantum mechanics, is consistent with the sonic gravity theory of everything in the Rosetta Stone of the universe. And that is a fact. Let me just demystify something real quick. You hear about quantum superposition of states. It's the probability that everything exists all the time at the same time, and Schrodinger's cat is alive and dead and all that kind of stuff. All that really means is, if you look at the energy off the hologram. If I tell you that the energy off the hologram is 6, you can't interact with it. There's too many degrees of freedom. You don't know what it is. Is it 6 plus 0? Is it 6 times 1? Is it 2 plus 2 plus 2? Or 5 plus 1? Or 12 times 1/2? Or 600 divided by 100, you just don't know. You can't tell. There's too many degrees of freedom about what that 6 off the hologram could mean. It's only when that 6 hits the hologram that you can make an observation. And so it's only when you make an observation and you go, oh, it's 3 plus 3. It's only when you make an observation that you understand the exact state of the energy and what that 6 is really kind of made of. And so it could be anything until you make that observation and check and see. That's all that means. It's not that tough. It really isn't. And that is a fact. But we can't stop there, because if the sonic gravity theory of everything is actually the sonic gravity theory of everything, then it also has to be consistent with the Dirac equation. Paul Dirac was a French physicist, and he took the Schrodinger equation, and he took Einstein's equations of special relativity, and he made a baby with it. He called that baby the Dirac equation. Now, Einstein's equations for the energy of mass is E equals mc squared, and that's for mass at rest. But if mass has momentum, then its energy kind of goes into 2 dimensions. One is it's sort of a dimension of matter, which is E equals mc squared, and then there's momentum, which is mass times the velocity times the speed of light. And mass times velocity is momentum, and that equals p. And they don't just add together. It's not just this plus that. It's kind of like, it's what you call Euclidean, right? It's vector dimensions. And all that means is that the square of the energy equals the sum of the squares of the momentum energy and the matter energy at rest. And that is a fact. And so you can kind of think of it like a diagram, like the triangle, like a right triangle. So the momentum is like across the x-axis, and then the energy of mass is like the y-axis. And so it would just be like, if the momentum was 4 and the mass was 3, then the total energy of that mass at that momentum would be 5. And you'd get that, and the momentum was 4, the total energy would be 5, because it'd be 3 squared plus 4 squared, which is 9 plus 16 equals 25. And so you take the square root of that, and square root of 25 is 5. So the total energy will be 5. And that is a fact. And in the next one, we're going to get a little bit more into that, because we're going to look at velocity as a dimension too. And we're going to see that the reason that muons look like muons, which are actually just fat electrons, it's because if they have a dimension of velocity which is orbital around a proton, and a dimension of velocity which is linear in an accelerator, and they accelerate that electron attached to that proton to near the speed of light, then that means its rotational dimension around that proton has to pretty much go to 0, because linear dimension of velocity is almost c squared is the maximum velocity, and if you're almost at the speed of light, that means you're not rotating, and then all of a sudden, bang, when your linear momentum is zorched by a collision, then you have an electron that ain't rotating around anything, and it ain't going anywhere, so it's big and fat. And we're going to see that when something isn't moving, it must have more mass. And then it doesn't decay, it actually just accelerates as an ion picks it up and starts spinning it around at close to the speed of light. And so the muon decays into an electron. And they think it gives off antineutrinos, but it doesn't. Those neutrinos are just kind of the skid marks in space-time from the G's that are pulling some of that mass into a dark matter state as it accelerates in velocity. And the consensus in particle physics is that the muon just poops out lots of neutrinos and gets lighter. They call that decay, but it's not. It just loses mass as it accelerates, and that is a fact. Because let's be honest, man, if the muon is really an elementary particle, it can't be an elementary particle if it gets smaller. And that too is a fact. Or if it's made up by neutrinos. So there's kind of this fiction that, oh, well, you know, it's just a matter interaction. No, it's not. It's just that mass is a function of velocity. And that is probably a fact. Maybe, probably. I'm pretty sure. Anyway, we'll get there. I'll draw it out. You'll see. It's totally easy. But watch, in this episode, that is going to do violence to the standard model, and that too is a fact. So now we get to the Dirac equation. The Dirac equation is what happened when a brilliant French physicist, Paul Dirac, decided to take Einstein's equations for the energy of motion and the Schrodinger equation and make them have a baby. And don't get nervous, I know it looks like math salad when you look at it, but it's really, really easy when you think about it. And in order for it to be right, and for Newtonian mechanics to be right, and for the Schrodinger equation to be right, they're all talking about kind of the same thing. So that if all of those are right, they have to echo, they have to be mathematically modeling the same kind of thing. And so when you look at it, you just kind of at first glance, you have the equation is 2 times the Planck constant times gamma mu. And gamma is not just like a number. Gamma is a bunch of matrices, and mu is the number of the matrices. So there's actually 4 in Dirac's formulation, 4 number grids. And the reason was because he tried to make it work out, and he couldn't make it work out unless he used 4 electrons. And the reason he had to use 4 electrons is because he needed a value, he needed to match values, he needed to equate the energies that were entering the hologram on one side, then leaving the hologram on that side, then coming back around and entering the hologram from the back side and going out the front side of the hologram. So 4 electrons, because he needed 4 objects and their interactions to model that energy, just like the sonic gravity theory of everything. We're going to go through all that in just a second, and it's really simple. It's just not that tough when you look at the sonic gravity theory of everything and the Rosetta Stone of the universe. But just know that that's not really a number. It's like a set of matrices that just needs to get like multiplied through, which is just the jiggle factor in different directions, in different dimensions, so to speak. And you take the derivative of that, all those changes with respect to the wave equation. So it's really just how does the wave equation change in all those directions? And then it's minus the mass times the speed of light times pitchfork. Which, it looks like a pitchfork, doesn't it? Well, it's psi, which is the value of the wave equation at that particular moment. And it equals 0. But do you see a similarity there? Yeah, the first term is really a kinetic term that talks about motion, which is really just a change in the direction and distance of the jiggle. And the second term looks a lot like the potential energy that we saw in Newtonian mechanics, when the rock was on top of the cliff. And back then, that potential energy term was just the mass times the height times the acceleration due to gravity, and that is a fact. And remember in Newtonian mechanics when we said that at the first time, all of the energy was potential energy, mass times the biggest height times the acceleration due to gravity. But then at the end, at the bottom, the time 4, where it like fell off the cliff and it was going as fast as possible right before it hit, it was all kinetic energy, 1/2 mv squared. And 1/2 times 4 is 2, which is in front of that first kinetic term in the Dirac equation, just saying. All of the energy was kinetic and the potential energy was 0. And the Hamiltonian said that at the very end, all of the kinetic energy, where it was all kinetic, had to equal back before when all the energy was potential. And so you have an equation that looks a lot like the kinetic energy at the end has to equal the potential energy at the beginning. So the kinetic energy at the end minus the potential energy at the beginning equals 0, because they have to be equal, because the Hamiltonian. Remember the Dirac equation, it ended with the Hamiltonian of pitchfork. And in the Dirac equation, we're assuming teeny weeny distances. And so what that looks like is that the kinetic energy, a teeny weeny change in the kinetic energy, has to result in equal a teeny weeny change in this mass potential. Mass times the speed of light times psi. I like to call it pitchfork. And I think the scientific consensus for the most part is that that value in that last term, psi, is what changes. Like m is constant, c is constant, and what's going to change is the psi. But here's the thing. I don't think it's just the psi that changes. The sonic gravity theory of everything, just like we said before, there's only like 3 kinds of energy in the whole system. There's the dark matter energy, which is the energy of mass off the hologram. And then there's kinetic energy on the hologram. And then there's the mc squared on the hologram. And we already said that in order for energy on the hologram to stay the same, if something speeds up, the mass part has to reduce too, because the energy on the hologram can't change. So you have energy of mass and you have energy of momentum. And if momentum increases, in order to keep the energy all the same on the face of the hologram, the mass has to decrease. We're going to talk more about that later. But essentially, I think what the Dirac equation is saying, at least in the sonic gravity theory of everything context, is on the surface of that hologram, you got a jiggle. And you know what? If that jiggle goes up, the second term, some mass has to come off so that it equals, so the change equals 0. And so just at a very high level, consistent with Newtonian mechanics, consistent with the Schrodinger equation, the Dirac equation is saying exactly what the sonic gravity theory of everything requires it to model. And that is on the surface of the hologram, if momentum increases, mass must decrease to keep the energy the same on the hologram. And that is a fact. Probably Probably, maybe, I'm pretty sure. But it doesn't stop there. That's pretty persuasive to me. But this next part, when we break down these jiggle matrices, this is going to freak you out. That is a fact. And I'm not kidding. When we start to unpack these matrices, these jiggle factors, you'll know for sure, and that is a fact. And that looks kind of scary at first, but it's really not. Because think of those number grids as like jiggle factors. And when you jiggle one and move one, it's going to actually kind of shake the other ones. And so when you put an input in there, it puts out a bunch of little factors in this grid. And that tells you how it jiggles everything else. And Paul Dirac wanted to model electrons that move in an electromagnetic field. And the things that you need to model, the inputs that you need to model when you do that, is the direction of a particle, the charge of the particle, a time component, which is actually modeled as positive or negative, lowercase italicized I, which is crazy because on the left or right side of the holographic surface of the universe, peeled off the quantum donut and hung like a sheet, to the left of that sheet is negative I, and to the right of that sheet is positive I, because that's off the hologram. That's time in the future and past. So when I saw that and I really looked at it, that's when I started freaking out, because when Paul Dirac had a baby, he was actually having a baby with the sonic gravity theory of everything, and that is a fact. And then the last piece is the force that acts on the particle in the direction, charge, and time direction of that component. It all goes by what we call the right-hand rule. Now, mind you, this is going to look like it was totally done in the context of the sonic gravity theory of everything and the Rosetta Stone of the universe, but it absolutely wasn't. I don't know how Paul Dirac figured out his matrices without the sonic gravity theory of everything, that our universe exists in a black hole and that time can be modeled like a movie reel, where the 2D holographic surface of the black hole captures the state of the energy at every point in time in the universe. And we can peel the two-dimensional holographic surface away from the black hole and hang it like a sheet. And if we do that for every instance of time from the beginning of the universe to the end of the universe, and stack them like we're chopping the frames out of the movie reel, from the very beginning of time to the end of time, then the distance across the slices of cheese, across the thicknesses of the frames, becomes time-like. And so then take one of those instances of time, the state of the energy in the universe at any one particular point in time, and look down the thickness of it. That's what the Dirac equation is modeling. All the matter and energy in the universe is orbiting in a circle, leashed to that instance of time by the Higgs field. And all that matter and energy is swinging around in a counterclockwise circle tethered to the surface of space-time, to the face of the hologram, to the surface of the black hole by the Higgs string. And imagine it swinging around in a counterclockwise direction. And the matter and energy in that orbit is going to intersect the hologram at 6 o'clock position and the 12 o'clock position. So the first electron that Dirac modeled was at the 6 o'clock position on the left, and we're going to call that A. Then if you follow around through the hologram to the other side, so it's at the 6 o'clock position, leaving the hologram into the future, that's B. And then it swings back up around, and it's heading back into the hologram at the 12 o'clock position, from the future into the hologram, that's C, and exiting the hologram into the past is the D electron. And look at how Dirac writes his matrices. The first column is A, the second is B, the third is C, and the fourth is D. And each of those matrices is going to be talking about a different quality. And each one of those electrons has a little bit different quality in one of the other attributes, whether it's direction or spin, the charge, or the electromagnetic force. They're all a little bit different. But if you track and you look at the diagram that corresponds to the right matrix, that corresponds to the right electron, the Dirac matrices reflect the sign convention of the electrons as positioned in the sonic gravity theory of everything, the Rosetta Stone of the universe. And that is a fact. And just like Newtonian mechanics, just like the Schrodinger equation, it's all about balance. The energy that goes from A to B has to equal the energy that pops out at C and goes from C to D. And that has to equal the energy that goes from D to A, and so on. Rinse and repeat. That is the Hamiltonian. It's the same in classical mechanics. It's the same in Newtonian mechanics. It's the same in the Schrodinger equation. It's the same in Einstein's equations for the energy of motion, and it's the same in the Dirac equation. And it's the same in the Rosetta Stone of the universe and the sonic gravity theory of everything. And that is a fact. And so as you can see, I'm filling in these Dirac matrices. The first column's the A electron, the second column's the B, the third is the C, and the fourth is the D. And I'm just kind of going around to each electron. And as I fill in the matrix, I'm writing in whatever quality I read off of the chart into the matrix, except for the fact that, and I know it looks like when I do that, I'm just reading it right out of the chart, but I'm not. I mean, that's actually in every textbook, that is the configuration of the Dirac matrices. And that last matrices is electromagnetic force, and you get that with the right hand rule. And so you can see, like, I'm pointing my index finger for any electron. I'm pointing my index finger in the direction of travel, and I point my middle finger in the direction of the charge, and then your thumb is the direction of the force. And so you just pick a sign convention, like the force is coming at you and that's positive, or it's going into the page and that's negative. Well, that's how you get that one. And what that means is the sonic gravity theory of everything in the Rosetta Stone of the universe is perfectly and completely mathematically described by the Dirac equation. And that too is a fact. And guess what? Did you see it? Did I sneak it past you? Did you see it? Yeah. You wanna know what antimatter is? Antimatter is the reverse trip back through the hologram from C to D. So antimatter is actually matter. The only reason it looks like antimatter is because our sort of primitive Cartesian positive, negative, XY sign conventions don't recognize the symmetries that arise from living on the 2D holographic surface of a black hole. Yes, antimatter is not a different kind of particle. It's just our particle, our matter, on the backswing through the hologram. And so matter and antimatter annihilation, it's not just when an antimatter particle zipping through the atmosphere hits a regular particle. The only time matter-antimatter annihilation happens is when matter achieves absolute rest. Because it's only when the 6 o'clock and the 12 o'clock position for the same matter make contact. And that's only going to happen in a Big Bang for reasons that we've already talked about, when a collapsing star rips out of space and time, or in a particle collider where the collision leaves some matter at absolute rest, where it has zero velocity. Because when it has zero velocity and there's nothing off the hologram, it's like infinite gravity in that one little spot. There's nothing oscillating around the hologram. It'll just all collapse. Probably crushes down past the Planck level. And then you get matter-antimatter annihilation. Probably. Maybe. I'm pretty sure. But yeah. And so when you realize that there's actually no different special antiparticle. And first I'm going to show you how general relativity is predicted by the sonic gravity theory of everything. The tension in the Higgs string bends space-time. The tether on the surface of the black hole, when it pulls, it's going to make a dip. It's going to deflect the space-time. But when you get to special relativity, and if you're not already convinced, when you realize that mass is a function of velocity, do you see it? Do you see what's going to happen to the standard model? Yeah, bigly. All right, so in this illustration at this point, what I've recapped is how the sonic gravity theory of everything, the Rosetta Stone of the universe, is not inconsistent with classical Newtonian mechanics or quantum mechanics described by the Schrodinger equation and the Dirac equation. In this illustration, I'm trying to demonstrate, in the movie reel, in the instances of time on the surface of the black hole, the first slice of cheese, the first frame, is without mass. So there's a vacuum expectation value for the Higgs field, and the scientific consensus on the expectation value of the Higgs field is 246 gigaelectron volts in the vacuum. The sonic gravity theory of everything, for reasons that we'll get into in a different episode or tutorial. The sonic gravity theory of everything proposes that the vacuum field value expectation is actually negative 246 gigaelectron volts, because the sonic gravity theory of everything proposes that the Higgs field is the gravity field, and gravity is negative energy density, so the Higgs field vacuum energy density must be negative, and that is probably a fact. Maybe, probably. I'm pretty sure. It is in the sonic gravity theory of everything. And so you can see, since gravity is tension in the Higgs string, and the Higgs string tethers all the matter and energy in the universe to the surface, the 2D holographic surface of our black hole, you can see in the second frame, see the little movie reel there, and then there's one frame that's a vacuum, and then the next frame over is one where there's mass in it. And you can see the mass is oscillating in a circle, tethered to the surface of the black hole by the Higgs string, where gravity is tension in the Higgs string that is leashing all the matter and energy there to our surface of the black hole, to our instance of Planck time. And that tension in the Higgs string, that pull, the leash that's leashing the matter and energy to the surface of our black hole, as that thing is oscillating around, it's actually pulling, it's deflecting the space-time. And it's that deflection, it's that dip that general relativity that Einstein said was gravity. And he's right, it is. And you can see how the sonic gravity theory of everything respects general relativity, because sonic gravity theory of everything proposes that gravity is tension in the Higgs string, and the Higgs string is what's leashing all the matter and energy to our instance of Planck time, to the 2D holographic surface of our black hole, which is a quantum donut. And it's that leash, it's that tension in the Higgs string that deflects space-time. You can see as it pulls on space-time, it deflects it. And general relativity says that that deflection is gravity. So the sonic gravity theory of everything is consistent with general relativity, and that is a fact. And so now we come to special relativity. And in examining special relativity and the sonic gravity theory of everything's compatibility and actually completion of the equations of special relativity and the energy of mass and momentum, we said before that the energy of mass, E equals mc squared, was E equals mc squared. In the God equation tutorial, we talked about how the actual energy of mass, including the dark matter, is 4 pi divided by the g factor of the electron times the observable mass times the speed of light squared. But for now, let's just keep it in terms of Einstein's special relativity equation, where E squared equals mc squared squared plus the momentum times the speed of light squared. And we know this is incomplete. We know this is wrong, because if we take E squared equals mc squared plus pc squared, and if we substitute the speed of light for the velocity, then we get E squared equals mc squared squared plus mc squared squared. Then when we take the square root of that, we get E equals the square root of 2 times mc squared. And we know E can never equals the square root of 2 times mc squared, because we know E equals mc squared. And it can't be both. And it doesn't work at the speed of light, and it doesn't work at 0.999 the speed of light. It just doesn't work. There's something missing. And that is a fact. And so like we've said before, the sonic gravity theory of everything's principle that resolves the issue, that unites the Lagrangian and the Hamiltonian, that completes Einstein's equation, is consistent with Newtonian mechanics, the Schrodinger equation, the Dirac equation, and is just kind of intuitively obvious. Explains everything from the G factor of the Einstein de Haas effect, general relativity and special relativity, particle collisions, and elementary particle finger quotes decay, end finger quotes, is that mass varies inversely with the velocity. When velocity goes down, mass goes up. When velocity is 0, mass is theoretically true mass with all the energy on the hologram. When velocity is the speed of light, the mass on the hologram is 0. The energy is still there, still has gravity, but it's off the hologram and can't interact with it. Maybe, probably, I'm pretty sure. And nothing on the hologram can ever accelerate anything past the luminal speed limit, because as velocity approaches light speed, mass approaches 0, and when you hit light speed, there's no mass on the hologram, so there's nothing to apply force to accelerate. And that is probably a fact. Maybe. Probably. I'm pretty sure. Buckle up, this is where we unify the Lagrangian and the Hamiltonian. Complete Einstein's equations for the energy of motion. And because there's no antiparticles, because it's the same particles circling back through the other side of the hologram, and because elementary particle mass varies with velocity, radically simplify the standard model for particle physics. And the reason that some of our matter is dark matter right now is because in our current inertial frame of reference, we're spinning around the axis of the Earth is revolving around the sun is spinning in an arm of the Milky Way galaxy, like on a pinwheel. The Milky Way galaxy is hurtling towards Andromeda, so the only thing that's really safe to say is that the Earth is in a non-zero inertial reference frame. And what that's like is like when you spit on the sidewalk, you're not going anywhere, but when you're inside your car and you spit, it looks the same. And so the reason that the equation for the energy of mass isn't actually E equals mc squared is because we're not on the sidewalk spitting. We're actually kind of in a car spitting. And mass, energy on the hologram varies with velocity, and we use dark matter in the geometry of the Rosetta Stone of the universe in a previous tutorial, in my first one, to derive the God equation. And we figured out that in our frame of reference, when our consciousness makes observations and takes measurements, the limitations of our consciousness and our ability to interact with mass and energy means we have to factor the energy and the mass that we measure if we want to get the true energy of mass. And we derived that. We called that the God equation, which is actually just the Einstein-Voorhees energy of mass equation, which is the same as E equals mc squared, except for it accounts for all of the dark matter off the hologram. And that equation is E equals 4 pi divided by the g factor times the observable mass times the speed of light squared. And the simplest, most natural equation that I could think of to model a relationship between velocity and mass is the cosine function. Because cosine of 0 is 1, and cosine cosine pi over 2 radians is 0. What that means is that when velocity is 0, the factor is 1, which is the identity of the true mass. 1 times the true mass. And I set up the cosine function, so at the speed of light, the cosine function will multiply the true mass by 0 and make it 0. Make the observable mass 0. So the sonic gravity theory of everything's equation for observable mass is the true mass times cosine pi v squared divided by 2c squared. That's the equation that gives you that. And that is a fact. And so if you graph that with the mass on the hologram on the y-axis and velocity along the x-axis, you see a cosine wave, and where velocity equals c, the mass is 0, and faster than c, the mass is negative, which means the mass is going back in time, which is exactly consistent with the sonic gravity theory of everything black hole genesis that we talked about in a previous video. And it's the same thing Einstein said, so you know it's right. Maybe, probably, I'm pretty sure. That's the sonic gravity theory of everything, anyway. That is a fact. And it also explains how, in collisions, which is the only way that these colliders ever get to see muons and tau particles and strange quarks and top quarks, is they have to smash these particles, which essentially takes them from the speed of light to 0 in an instant. And all of a sudden, these big, fat, heavy particles pop into existence. And we think the particles that were this big were always there, but we just released them when they crashed. And then they just decay. They just get smaller for some reason. That's not what happens. They just get picked back up into the environment, start oscillating, and they oscillate at close to the speed of light, so that's why they shrink. That's why they lose observable mass, is because they speed up. Not linearly, they speed up by oscillating, by getting picked up by something and spinning around really fast. Because that's still a velocity, and that is a fact. Now, for the last 40 minutes, we've been talking about the sonic gravity theory of everything, how it's consistent with Newtonian mechanics, quantum mechanics, it's internally consistent with general and special relativity, and we learned that antiparticles are just the same particles we have, but just backswinging through the other side of the hologram as it orbits the holographic surface of the black hole. And we just showed that mass is a function of velocity. Now watch what that does to the standard model. Yep, say goodbye to all the antiparticles that are just regular particles swinging back through the hologram in the opposite direction. Say goodbye to the 3 generations of matter, because it's the same matter going a little slower. And we'll see shortly that the Higgs is actually responsible for bending space-time, which is gravity, but mass is determined by the action of the Z boson, but that's a function of the geometry of space-time. And this is when I realized, actually when I was doing this diagram, and I figured out that the thickness of the hologram isn't actually 1 Planck length. Can't be 1 Planck length. It's actually a Planck constant, I'm pretty sure. And I figured that out from the Dirac equation. And if you look at the derivation of the Schrodinger equation way back when we took the integral of the Planck constant to simplify the equation, and when you look at the Dirac equation, the space-time integral is 2 times the Planck constant, which might reflect 2 passes through the thickness of the hologram. And then if we say, and this, what I'm about to say, this comes from a lecture I saw, a free Stanford lecture I saw on YouTube by Leonard Susskind, who said that mass is actually a function of the amount of interaction that energy has with the Z boson. And the sonic gravity theory of everything would add on to what Leonard Susskind said, is that mass is a function of the amount of interaction the Z boson has with energy oscillating around the surface of the hologram, based on the amount of contact it has with the hologram, which makes perfect sense because as the Higgs bends space-time, if it's elastic, the more it bends it, the more it thins out. The thinner space-time gets, the less interaction it will have with the Z boson that I believe carries energy through the hologram. And so the more space-time is deflected by quantum gravity, the less interaction it has with the Z boson that exists in the hologram, in the thickness of the hologram. And I'm going to talk about neutrinos as the fabric of space-time in just a second, but I need to cover the quark really quick, because the quark was a little bit gnarly, and it took me a minute to sort of figure it out. Because the up quark is 2.2 mega electron volts. The down quark is 4.7 mega electron volts. And the charge of the up quark is 2/3, which is kind of weird, right? You wouldn't think that. It's strange. How could you get 2/3 charge? And the charge of the down quark, and it's heavier, is negative 1/3. Well, all physicists know that there's 3 quarks inside a proton. So when we put 3 spheres next to each other, it can only ever be in a triangle, right? And if we reflect on the Dirac equation's derivation of the Dirac matrices, and we apply that and stick that triangle on top of the charge matrix, we can see we're going to have 2 quarks. And if we assume a net positive charge sort of on those quarks, we're going to have 1 quark probably stuck to the bottom where the negative electron is, right? Because they're going to attract. And then we'd have two quarks in the upper section of the charge diagram, but they would be repelling, right? And the only way to get the furthest distance from that positron up there, which is a positive charge, and the positive two quarks that are there, is to kind of have two kind of spaced out equidistant. And look, the masses are different too. The mass of the down quark, which is in the bottom, in the negative charge side, which is why it's negative 1/3, is going to be moving a lot less than the two up quarks that are probably not just rotating, but spinning laterally. And so they're spinning laterally. That's sort of a different dimension of velocity that the down quark, finger quotes, doesn't have. So that's why the up quark has 1/3 charge and is half the observable mass of the down quark, which has a minus 1/3 charge. Because in the Dirac matrix, if you're in the bottom, you have a negative charge. If you're in the top, you have a positive charge. So everything makes sense. There's no way I couldn't make this up. And the only way that the sonic gravity theory of everything can account for this, the fact that all the matter and energy in the universe is oscillating, leashed to the surface of space-time, which is the 2D holographic surface of the black hole. That's the only way you get here. And no matter what you throw at the sonic gravity Rosetta Stone of the universe, everything is explained. It's unbelievable. It's unbelievable to me. We nailed it. We have the theory of everything. And that is probably a fact. Maybe. Probably. I'm pretty sure. So the mass would get lighter. So everything makes perfect sense. It's all internally consistent. And then you think, well, what comprises? What's the Higgs actually bending? What is the substance of the hologram? And I think that might be what the neutrino is. The neutrino might be the grid paper that is the surface, that marks the surface in time of the hologram. And they say that billions and billions of neutrinos pass through us all the time. And that's why I think that it's possible that the fabric of space might be the neutrino. And we're sitting on the hologram, and then my mind just exploded, and it felt like my brain was racing through space, and I achieved illumination when I remembered this.
Except, the thing is, even if I believed you, right, where you're from, what I've done, which I don't, by the way, you're still talking about beaming aboard the Enterprise while she's travelling faster than light without a proper receiving pad. The notion of transwarp beaming is like trying to hit a bullet with a smaller bullet whilst wearing a blindfold, riding a horse. What's that?
Your equation for achieving transwarp beaming.
Get out of it. Imagine that. It never occurred to me to think of space as the thing that was moving.
Because the sonic gravity theory of everything holds that space-time blows out of black holes. And if time is passing through us, there's no reason to think that space isn't passing through us too, because it's not time, it's space-time. Which actually accounts for universal expansion, cosmic strings, high neutrino density squirting out from within the donut hole of the black hole universe. Black holes are all quantum donuts, just saying. And it explains why black holes become pulsars, because there's a bunch of space blowing out of the donut, all bunching up in the middle, inward into the hole from all directions, at each other, and so it has to squirt out the top and bottom really fast, just saying. And so everything fits, all the puzzle pieces fit. And if billions and billions of neutrinos are passing through us all the time, then it's hard to argue that the neutrinos aren't space-time, and space-time isn't passing through the 2D holographic surface of the black hole, which is a quantum donut containing our universe. And that is probably a fact. Maybe, probably, I'm pretty sure. It's definitely the sonic gravity theory of everything, and that is a fact. And we actually haven't even scratched the surface of the things that the sonic gravity theory of everything predicts. But let me blow your mind really quick. If space-time is actually blowing through the 2D holographic surface of the black hole, which is a quantum donut, and space-time blowing through the hologram is changing the hologram, which is what we notice as the passage of time. And if space-time needs energy to change the hologram, and our consciousness also uses the same energy to run our brain, the energy for those synapses, for those neurons to fire, has to come from somewhere. And if the energy on the surface the black hole is constant and fixed, and we have no reason to think it isn't from the law of conservation of mass energy, then our neurons might compete for the same energy that space-time uses to change the hologram. And if we compare the neuron density of the hummingbird, which is 650 million neurons per gram, and the human, which is 53 million neurons per gram, it's possible that the consciousness of the hummingbird deprives space-time of much more energy it needs to change the hologram than the human brain does. If the hummingbird's consciousness is sucking way more energy off the surface of the black hole than the human brain's neuron density is, that might account for hummingbird celerity. The consciousness of the hummingbird and its high neuron density might be slowing the flow of its time, which means it doesn't move lightning fast because it has fast muscles. It moves lightning fast because it has slow time. And that is probably a fact. Maybe, probably. I'm pretty sure. And if our active consciousness is actually constipating the flow of time, causing a time jam, the psychic pressure on our consciousness under the arrow of time might be what makes us tired. And that could be a fact. Maybe, probably. I'm pretty sure. And maybe that's why the muscles that our consciousness controls get tired. But our heart, it could beat for 70 years solid. Never stop. Well, until you die, anyway. And the bumblebee that beats its wings 600 times a second with a neuron density of over 1 trillion neurons per gram. Well, the sonic gravity theory of everything seems to be the least silly explanation for the unexplainable. And that is a fact. And you know, it really is a theory of everything. You know, it's the theory of everything. When it starts predicting solutions that match verifiable reality, and those solutions are solutions to questions we didn't even know we weren't asking. And that is a fact. So the Rosetta Stone of the universe, the sonic gravity Rosetta Stone of the universe, predicts and explains things all around us that we haven't even thought of as mysteries yet. And that too is a fact. And I know we're running long, so we're going to hurry up and finish. And when we write Einstein's equations of motion, you're going to see that we actually, at the quantum level, we're actually going to unite the Lagrangian and the Hamiltonian in a single equation. Maybe, probably, I'm pretty sure. You be the judge. But if we do, and in just a second, when you see it, you'll know it. And when science goes, yeah, that's legit, we're going to call it the Voorheesian. That too is a fact. And so I talked a little bit before about how Einstein's equations for the energy of motion were incomplete. And my initial notion of that came when I just looked at the equation E squared equals mc squared plus pc squared, where p equals mass times velocity. Because at the speed of light, E squared, when you plug everything in, then E becomes square root of 2 mc squared. And E should be mc squared. And it couldn't be right. So I didn't think that Einstein's equations for the energy of mass and momentum, I didn't think they could be right. And I'm pretty sure he knew they weren't right either. But the scientific community is under the misimpression that mass approaches infinity at the speed of light instead of 0. And the reason they're confusing that is because there is a luminal speed limit, but it's not because everything gets super duper massive as it approaches the speed of light. It's because its mass goes to 0, and at the speed of light, its mass is 0, and you can't accelerate it past that. And that's the same, and that works out in the math the exact same way that the free energy electron does in Feynman path integrals. And every physicist knows that for most of the orbit, when the electron is off the hologram, the math says the electron's mass goes to infinity. And everybody knows that doesn't happen, and so they cheat. And they just say, well, we know our mass says it goes to infinity, but we don't care. We're just going to substitute in what we know the mass is. And that is a fact. So it's just another example of when things go off the hologram, our current mathematical models just flip out and don't know what to do. It's not because they're like not smart or don't know what they're doing or anything like that. They absolutely know what they're doing. They're brilliant physicists. Trouble is that the mathematical models that they use in the paradigms weren't derived with the symmetries that are embedded in the sonic gravity Rosetta Stone of the universe. And that is a fact. So I couldn't really use the whole equals the square root of 2 times mc squared at the speed of light to illustrate the shortcomings of Einstein's equations for the energy of mass and momentum, because the first line of defense for any consensus physicist would be, oh, well, that's because mass goes to infinity. And so talking about conditions at the speed of light wouldn't be fruitful. So I had to come up with an illustration that was lower energy, but just as persuasive. And so I thought up the velcro astronaut problem. And so we know from the sonic gravity Rosetta Stone of the universe that the 2D holographic surface of the donut, the black hole that is our universe, you can peel the surface of that black hole off at any instance in time, and whatever's on the hologram is the complete state of existence of the universe in that instance of time. And you can hang that 2D holographic surface like a sheet, and that's like a frame in a movie. And if you want, you could take the entire reel, every state of the energies in the universe from the very beginning of time to the end of time would be encoded as frames in that reel of movie film. And you could chop all those frames out and stack them from the beginning of time to the end of time. And the energy, the mass and energy leashed to the surface of all of those frames has to be equal from the beginning of time to the end of time. And that is a fact. And so now what I want you to do is somewhere in the beginning, I want you to imagine 2 spheres, 2 bubbles. And those are what we call closed systems. No energy comes in or out of them bubbles. And in that frame itself is a closed system too. No energy goes in or out of that frame. It all has to stay the same. And inside those bubbles, I want you to think of two astronauts that are kind of squatting down. They're back to back, each inside their bubbles. And they're in these Velcro suits. And the inside of the bubble, except for where their feet are, is all Velcro too. Except it's the opposite side of the Velcro, so like it'll stick to them. So in one earlier frame, their bubbles are right next to each other. They're squatting down, facing opposite ways. And then somewhere in the middle, they both jump at the same time. Their bubbles are still together, but they're flying through the middle of the bubble until they both hit the opposite side of the bubble and they stick. The Velcro sticks them. Now the momentum that they created when they jumped transfers to the total mass of them plus the bubble when they impact the far side of their bubble. And so then the bubbles start moving apart. They have to because of conservation of momentum. And so then at some time in the future, after they've jumped, after they've stuck, and after the bubbles start moving away from each other, it's a closed system. So the energy all has to be the same. The energy in the first frame when they're still, and the energy in the last frame when both the bubbles are moving. And no matter what the Velcro astronauts did inside the bubble, doesn't matter because the bubbles themselves are closed systems. So whatever happened inside the bubble, all of the energy of the bubble and inside the bubble is the same as it was before too. And now there's a big problem, because if Einstein's equations of motion are correct, then in the first frame, the energy has to be E equals mc squared. But in the frame of the future, when the same bubbles, the same mass, they're still both in the frame, but now there's no denying that the bubbles are now moving too. And what that means is, in the first frame, the only energy is E equals mc squared. And in the second frame, the energy is E equals mc squared plus the energy of momentum that has to account for the movement of the bubbles, which is non-zero now. And the total energy in the first frame, where the bubbles aren't moving, has to equal the total energy in that last frame, where the same bubbles are there, but now they're moving. And everything that's in that equation, and that's the one that's E squared equals mc squared squared plus pc squared, has to be equal to mc squared in the first frame. And it is. It has to be because of conservation mass energy. But the only terms that can be variables in those equations between the first frame, where E squared equals mc squared squared, and the future one, where E squared equals mc squared squared plus the quantity pc squared, there are only two quantities in that equation that can possibly be variable. C is a constant that never changes because of the invariance of the speed of light, and E is a constant that never changes because of the law of conservation of mass energy. There's only velocity, which we know is increasing, and the only term that's left in the equation is mass. And the mass is what changes, and that is a fact. The mass changes because it must. The observable mass must drop to make room for the increase in the energy of momentum in order to observe the law of conservation of mass energy, and that must be a fact. It's the only way. So the sonic gravity theory of everything has to complete Einstein's equations. It has to connect a mechanism that allows velocity to reduce mass. It's not reducing the total mass. Some of that mass is just transmuting into a dark matter state, and the observable mass is what's dropping. The observable mass on the hologram is what drops a little bit. And it's the acceleration, it's the increase in the velocity, it's the G's you feel. That's the feeling you get when some observable mass comes off the hologram and enters a dark matter state. And so what we need to add to Einstein's equations of motion is a term that accounts for the dark matter. And the funny thing is when we make that term the dark matter mass term, and if we think of that as mass potential the same way we do in Newtonian mechanics, remember where the Lagrangian equals the kinetic energy minus the potential energy. So we know from the Lagrangian that we have to subtract the potential energy, which is the dark matter mass energy. So now we don't really have mc squared anymore. We have m observable c squared times pc, and the second term, pc, which is mass times velocity, we have observable mass times velocity. And those two terms, the energy and the mass on the hologram, that's what we're going to consider kinetic energy in this context. And for the Lagrangian, then we know we minus the potential energy. And the potential energy is the dark matter mass, which is like E equals mc squared for the dark matter mass. But we can just call it dark matter mass, or MD. And now we have a really interesting extra equation that comes out of that, and that is the true mass equals the observable mass plus the dark matter mass. So the complete Einstein-Voorhees equation for the energy of mass and momentum is the God equation squared, 4 pi divided by the G factor times the observable mass times the speed of light squared. which is the total E squared, equals observable mass times c squared, plus the observable mass times the velocity times c, all that squared, minus md, which is the dark matter mass, times c squared. We have to multiply it by our little lowercase italicized I because it's off the hologram, then all that squared. And the beautiful thing is that at the speed of light, the observable mass drops to 0, and the first two kinetic terms drop out. So then all we have is minus the dark matter mass times the speed of light squared, and that is squared. But when you square I, you get -1. And so at the speed of light, E equals negative mc squared times -1. E equals mc squared, and that is a fact. And by characterizing the observable mass and energy on the hologram as kinetic energy in the context of the Lagrangian, and subtracting the potential mass energy, which is the dark matter mass, defines consciousness and explains its role in limiting our ability to perceive the universe with our observations and measurement, that equals the total energy, and that is a fact. So the sonic gravity theory of everything and the sonic gravity Rosetta Stone of the universe unites classical mechanics, quantum mechanics, including the Schrodinger equation and the Dirac equation, explains the increase in mass and the mass decay in experiments and particle collisions, gives us the theory for quantum gravity, validates the principle of the holographic universe, models general relativity, embodies general relativity and special relativity, and in doing so unifies the Lagrangian and the Hamiltonian, simplifies the standard model, derived the God equation, accounts for universal expansion, and that is a fact. But the sonic gravity theory of everything doesn't end there. This is just the beginning. You see the black hole M87, the quantum donut? It's a ring. It's a ring that ripped out of space and time when the collapsing star and the law of conservation of angular momentum forced the core at some radius to spin faster than the speed of light. It ripped out of time and left a quantum donut. And inside, a new universe big banged. And you see those ridges that ring the M87 quantum donut? You see those rings around the ring of M87? All those ridges? Those ridges are rings too. Black holes within the black hole universe of M87. And that is probably a fact. Maybe, probably. I'm pretty sure. And if our consciousness is in fact energy running over the 2D holographic surface of the black hole that is our universe, then that means when we die, our energy leaves the surface of the black hole as Hawking radiation, carrying with us the information that we've recorded in our memories and DNA, because we are the universe's mechanism for the law of conservation of quantum information, where our consciousness enables us to make observations, and our intelligence enables us to assimilate and connect our observations, and where emotion enables us to deeply etch that information into our memories. Because everyone knows that you can forget information almost immediately, but you will remember how something made you feel for years, maybe even your entire life, and that is a fact. And when we die, our energy and information, which cannot be destroyed under the law of conservation of mass energy and the law of conservation of quantum information. So yes, our souls are immortal, and that is a fact. And when we die, we leave the surface of the black hole, perhaps in fractal ascension to our parent black hole, the black hole that contains our universe. And if we hit the surface of that hologram and manifest inside that universe the same way we've manifested in this universe, that could be reincarnation. Or if we ascend to the primordial black hole, to the first black hole, we might find ourselves, our consciousness might find itself manifesting in what we could only call heaven. And that too is a fact. So this isn't the end, it's just the beginning. In the same way, time travel, UFO flight, zero-point energy propulsion, immortality, anti-gravity, it's all here in the sonic gravity theory of everything. And when you orbit in sonic gravity and see the universe through the eyes of a madman, you'll stare into madness, and madness will stare back into you, and you'll know for certain. And the next time you stare at a picture of M87 and see a quantum donut, and the rings around that quantum donut as the black holes within M87, and you will know that I am inside your mind too. That too is a fact.